Hello everyone. Today we are going to see how to implement the logistic regression for Iris dataset. So data that we are already familiar with. So for that, dataset will be like this. First level will be a ID, then sepal length, sepal width in centimeter, petal length, petal width in centimeter as well. And our model should specify the species for that based on the sepal length, width, and petal length and width. So if I am providing these four inputs, what can be the output? Whether it is Iris setosa, whether it is Iris versicolor or virginica, that my model should predict. So it is a classification based problem. Categorical output nature is there. That's why we are going with a logistic regression here, and we'll see how to implement a logistic regression for the same. Okay, so first we need to import the libraries. Those are required. So basic libraries, those will be needed. Those are like NumPy, Pandas, scikit-learn, matplotlib, seaborn. These libraries I will need. So first of all, I will import the NumPy. Import NumPy as np. Second thing, import pandas as pd. Then we can go for the visualization. For visualization purpose, I can import two libraries there. Visualization. It is seaborn and matplotlib, right? So put matplotlib, import matplotlib.pyplot as plt, import seaborn as SNS, and after that we can go for this splitting, train test splitting. We can do train test splitting. For that, we need to import a train test split from the model selection. So import or from scikit-learn or model selection. From scikit-learn dot model selection. Import train test split. Import train test split. Okay. In order to build a model, what we need to import? For model building or to call a model, you can import from scikit-learn.linear model. From scikit-learn.linear model, import logistic regression. And last one is a evaluation. For evaluation purpose, I can import from scikit-learn dot matrix, import confusion matrix, then classification report, and accuracy score. So we'll work on these three metrics as of now. Accuracy score. So these are the required libraries in order to work on a logistic regression or any classification problem. The change will be only a logistic regression model. If you're working on a decision tree classifier, then all other things will be a similar one. Just you need to call a decision tree classifier over here. Okay. So after that, after executing this, I will call the data. So df equal to, I will create an instance with a df, data frame is equal to pd.read CSV. I'm having the CSV for Iris data. So Iris dataset CSV call karaide. Iris CSV and just call a df. So it will be look like this. First column will be ID, second is sepal length, then sepal width, sepal petal length, petal width, species. So these five will be an input one and species is your output. As ID is not needed, it is not like species is not based on the ID. So that's why we will go with these four input columns. There is a sepal length, sepal width, petal length, and petal width. Okay, how many columns are there? 6 columns are there and 150 records are there, 150 rows are there. Okay, if I check the information about the data frame, what it is giving, df.info is giving me the like information about the data frame. Total 150 entries are there. Index values are from 0 to 149. Data columns are total 6 columns are there. We are having the like label of each column along with how many not null values are there. That means 150 not null values are there. That means there is no null value. Data is clean. Data type of each column. So first column is integer, other columns are a float, species is an object. So you need to work on a species only over here in order to convert this symbolical representation or symbol representation into the numerical one. Okay, so you need to work on one column only in this case, right? So if I fetch like from df spaces, how many unique values are there, I don't know, right? Unique values from the spaces column, I will get like this, df of spaces dot unique. So I can get, there are 3 unique values, iris setosa, iris versicolor, iris virginica. These 3 values are there, and I will do the encoding, manual encoding I will use over here. Df spaces is equal to df spaces data frame and spaces column. Then go for the replacement of the values, replace, provide the dictionary for the above values. Okay, first thing will be iris setosa. If I use a label encoding, it will take like setosa as a 0, virginica as a 1, and versicolor as a 2, like alphabetical way. Okay, so iris setosa I will take a first one. Iris setosa should be replaced as a 0. Then second one, iris versicolor should be replaced as a 1. Then iris virginica should be replaced as a 2, and this replacement should be a permanent one. That's why I will go with in place equal to true. It should be a 2, and after that provide argument in place equal to true. In place equal to true. So it will do the changes in original data frame. In original data frame, I will have the object, instead of object there will be a float or integer. Okay, so we'll check this whether it is working or not. So it is executed, then check df.info, what it is giving. Df.info is giving me all, like still it is object, 0 not null values. Okay, something is missed over there. Iris setosa. Okay, something is missing over there. Iris spaces, df spaces is equal to df spaces dot replace with these values. Okay, iris setosa, iris virginica, iris cheek. If we execute this, what it is giving, none is there, array is a null. Fine. Okay, execute from the first. Df is equal to so and so, then df. Okay, information. Okay, there is one mistake, like apology for this. If we are taking an instance, I'm taking instance over here, df spaces, so it should like there should be in place equal to false. Okay, so this is how it will work. It is integer now. Okay, so it's like temporary change, we can say. I'm replacing this column. Okay, there should be in place equal to false, in place equal to false, right? So if we check any null values are there or not, df dot is na dot sum, so it will give me the values, null values in each column. So there are no null values. We can go for the like next step. Before that, what we can do, we can drop this id. It is not needed so far, right? Spaces is not depend on the id of the record or id of the row. So that's why I will drop this df dot drop. Df dot drop. What I need to drop? I need to drop id column. Okay, and it should be in place equal to true. In place equal to true. So it should replace from the original data frame itself. Okay, and after that, if you check df dot drop id column in place equal to true. Okay, why it is not working? df dot drop id column. Okay. We need to provide axis here from where we need to import drop this. So we need to drop this from the axis equal to 1. So it's a drop df dot info. If we check, so there is no id column so far, right? Only 4 columns are there, 4 input values are there, and on these 4 input values species is dependent, right? Now I'm going to split the data into training and testing data set, okay. x is equal to df dot drop. So it's a temporary dropping, okay. It will be stored in a x variable. Df will be as it is, original df will be as it is, df dot drop spaces column comma axis equal to 1 y equal to df of spaces. So whatever dropped in x, that should be considered as a y. So this will be your input, this will be your output data frame or output series, okay. So if you check what is there in x, what is in there y, you can check. I will go for the splitting the data into training and testing. X train, one variable is there, x train comma x test, then y train comma y test, these 4 different parameters will be there, and I will do this with the help of train, test and split. X data, y data, test size is default 0.7525. If you need to change it, you can give the another value as well. If I'm not giving anything, what it is taking, just take a look. Parameters test size, so it's a 0.25 default. So I'm taking it as suppose 0.30, 0.3. If I'm not giving anything over here, it will take it as a 0.25. Okay, 25% data will be used for the testing. Random state equal to 42, developer friendly value that generally developers are taking. Okay, so these 4 different attributes will be there in order to splitting the data. Okay, if you check this, you can check y test, what is there in y test, what is there in x test. After that, we will go for the model building. In model building, just take a look how it is working. Model building. So for model building, you will have, suppose I'm creating the instance logistic regression is equal to call the logistic regression. Okay, create instance for a logistic regression and feed your data on a logistic regression. LOGREG, that is your instance dot fit. Which data you need to fit? You need to fit x train and y train data. So model will learn on this data, x train and y train data. On this data, model will learn, model will be trained, and this will be used for the training purpose. Okay, y train is not defined. Okay, spelling mistake is there. Okay, so logistic regression instance is created. In order to predict the output, what we can do? Ypred is equal to logistic regression instance is there. Logistic regression dot predict from the x test. So this data we have kept aside in order to evaluate the model, and you can call the ypred as well. Ypred. So these 30 will be your predictions, 30 or 45, 30% data, that is 45 values are there, right? Y prediction values are like this. In order to check the accuracy, what you can do? Accuracy score. How you can check the accuracy score? In order to check the accuracy score, what you can do? You can call the accuracy. Suppose I can call it like accuracy is equal to accuracy score of accuracy score of y test. Those are your original values with a data frame or in dataset or in CSV, whatever actual values are there, those you have kept aside. So those are the actual value, and you will compare these values with the prediction. Okay, y pred, and accuracy would be, what is the accuracy? Accuracy of model is a 1.0, so it's overfitted model, right? What it is giving? Overfitted model. The data is like very ideal, that's why it is giving the accuracy like this. Okay, if you change this, suppose random state, or if you do some hyperparameter tuning in this case, it will give you the different result maybe. Okay, so if I am changing here, if I'm using random state equal to 1, so some changes are there, iterations has been changed, so 97% accuracy it is giving now. So it all depends what random state you are giving, what splitting you are using, what hyperparameters you are trying. Actually, there are no hyperparameters for logistic. In upcoming models, you can see the things related to hyperparameter. If we print the confusion matrix for the same, confusion matrix, which will give you the actual scenario for the true negative and true positive values, confusion matrix. What do you need to call? Confusion matrix you already imported from scikit-learn.matrix. You are imported the confusion matrix, you are imported the accuracy score, and we also do the classification report import. But let's see, as there are three labels over here, so it should be a multi-label confusion matrix. We will try with the confusion matrix first, whatever we have seen for the Titanic dataset binary classification. So I will try, suppose confusion matrix of y test. Obviously it may give you the wrong results or like error may be there, but let's take a look. We will rectify it. Confusion matrix will be like this. So true negative, true positive, so this will be your confusion matrix, but we are not getting the like perfect thing from it, right? As there are 45 values, we know 14 plus 17 plus 13, so total 14 values are there, sorry 45 values are there. Out of 45, scenario is like true negative, true positive, but I just want it in a multi-label way. So for that we need to import from, if multi-labels are there, like multi-class classification is there, we need to import from scikit-learn.matrix import multi-label confusion matrix, import multi-label confusion matrix, and just provide the values for the multi-label confusion matrix here. So it will give you the proper scenario. So confusion matrix for a 0, confusion matrix for a 1, confusion matrix for a 2, like this. So 0 as a 0, 1 as a 1, and this is like this one. So two values are like misclassified over here, you can see, right? So 0, 1, 2, like this scenario is there. And if you want to print the classification report for the same, what do you need to call? Classification report of classification report of y test and y pred. So classification report would be like this. So actually just write this way, proper format, classification report, you can say report, and just print. So it will give you the proper structure, class report, print class report. Okay, so this will be like this. Precision is so and so for 0 class, for 1 class. So Setosa, versicular, virginica, like these classes are there, right? So these are the things related to it. Okay, one versus rest, like that you need to, if you want to build a model based on the one versus rest, like that you can do the same thing. Okay, so these are the like important things related to Iris dataset for the logistic regression. If you want to do the another analysis, suppose this is overfitted model, I just want to build other model as well, logistic regression 1, suppose logistic regression 1 is equal to logistic regression of multi-class. It is a problem of a multi-class, so you can provide different things as well. Multi-class is equal to different classes are there, penalty equal to 12, this is something there. One versus like multi-class is equal to, you are having something in a multi-class, so what we can provide in a multi-class, OVR 1 versus rest, like that you can provide in a multi-class. L1, L2 warning, verb is deprecated. Okay, fit intercept, scaling, last test. Okay, solver, library chain, warning, verbose jobs, attributes, coefficient, intercept, feature name. Okay. So just provide over here multiclass is equal to OVR 1 versus rest. OVR stands for 1 versus rest. So this will be like type of one of the analysis for the multi-class problems, 1 versus rest. Okay. And just fit your data, logistic regression, one instance is there, dot fit same data, X train, comma, Y train. Okay. And then check the accuracy, right? Suppose Y prediction, Y pred using OVR is equal to Y pred. Here you can see multiclass is equal to OVR that we are taken into the consideration. Y test OVR is equal to logistic regression 1 is your instance dot predict what do you need to predict? X test, right? Y pred OVR. Okay, so these will be the predictions using the OVR method, 1 versus rest method. In order to check the accuracy, you can use the same thing. Accuracy is equal to only your Y test pred will change. Y test pred should be Y test OVR. Accuracy using OVR you can give it over here. Accuracy using OVR. So it's 86%. So it's like little bit more accuracy, or like overfitting is avoided in this case. Right? Same thing you can do for the multi-label as well. Multi-label confusion matrix. Instead of a Y pred OVR, you can provide Y pred OVR again. It will give result like this. Okay, so this is how it will look like. For classification report as well, also you can provide the same thing. Classification report, Y pred OVR. Just a minute. Okay. Y pred OVR class report is equal to. So this is a classification report using the OVR. It will be like this. Okay. So some changes are there in a precision. You can observe. So this is how you can build a model for logistic regression based on the Iris dataset. So I will provide the link in the description of this video for this Jupyter notebook. You will find this Jupyter notebook. You can use this as it is. For the dataset as well, you can use the same link, GitHub link I am providing in the description of this video. If you like this video, please share, like, and subscribe. Thank you.